Okay, so as promised, I'm going to go through a couple of examples for the horizontal projectiles, figuring out how to do the math and things like that. So this is example one. This is a stunt car. This is from the movie Thelma and Louise. And what we have is a stunt car is driving off the cliff horizontally at 14 meters per second. So based on our drawings that we have been doing, we've got, let's see, this car is going outward like so at a Vx of 14 meters per second because horizontally. If the cliff was 50 meters high, well, that is a vertical. And so I've been using blue to denote vertical. So that is height. It's not a velocity. It is how high the car is from said ground. Now in the picture, we can't see the very bottom of this valley, so I'm just going to draw it further down the picture. All right, so let's see, that is going to be our dy. And since the car is going down, it will be negative 50 meters. Okay. Then it's asking us how far out from the cliff. Well, that's going to be going that direction. So I guess that's going to be another x, isn't it? So from where the car started to where it landed, that is what we are looking for. Well, that displacement is dx. The trajectory should look something like that, right? Our half parabola that we've been talking about. All right, so what we're going to do is we're going to make that chart of variables, right? And so here's the chart. And let's see, let's do red first. So x. Let's see, we've got, no g. We have Vx, which is 14. And dx, well, we have t, we don't know. And then we have dx, which is what we're trying to find. All right, we automatically realize that if we're trying to find dx, then obviously we need to find time. Okay, well, how can we do that? Well, let's look in the vertical, because time is the only thing that ties the two sides together. And so I'm actually going to use purple for that, because red and blue make purple. So on the y side, we have g, and that's negative 9.8 meters per second squared. We do know up here the initial velocity in the vertical, that is going to be 0, because at the top it is stopped. And that is only in the vertical though. So VIY is going to equal 0. Okay, we don't have time, but hey, we got dy. That is negative 50 meters. All right, so there's our chart. So let's see, on the x side we have 2 unknowns, on the y side we only have 1 unknown, so of course we're going to use the y side. Our only equation that we talked about that you will use on that y side was this one. Let's see, VIYT plus 1/2 GT squared, or you could write it the other way around, right? Because I think I did both in different classes. But as you can see, they're the same thing, same equation. Let's see, nonetheless, let's see, we got negative 50 equals, all right, I'll just use this bottom one since it's the closest one to me. 1/2 of negative 9.8 times t squared plus 0 times t. That goes away. We have negative 50 equals negative 4.9 times t squared. Big mistake I see a lot of students do with this part in terms of the math is since they see this negative in front of the 4.9, they want to add the 4.9 to the other side. You can't do that. It's negative 4.9 as a number times t squared. So what we have to do is divide by the negative 4.9. And when we do that, it's going to give us, on this side, we get 10.204, and on this side, we get t squared. Now to get t by itself, we have to take the square root. That leaves us t over here, and on this side, it leaves us 3.19 seconds. All right, now since that time is over here, it's going to be the same time over here. Hey, now we can solve the x side, right? All right, the only equation we can use on the x side was this one. Also written as this. Same equation, just rewritten slightly differently. I would go with the second one here since we're looking for dx. And so dx equals 14 times 3.19. And that gives us 44.72 meters. And so how far did this car land? It landed 44.72 meters out. All right, now let's do example 2. Example 2 is very, very similar to example 1. This time it's a cliff diver. Notice it says professional. So I am not saying that you guys should go out there and start going cliff diving. You need to really know what you're doing to go cliff diving, okay? So professional, bolded and underlined. All right, let's see. We got a 15-meter cliff. That is going to be how tall it is, right? So that is going to be our height. So the cliff, and again, it goes off the screen, right? That is going to be 15 meters. Since he is going to be going downward, it's going to be negative, and that is our dy. If he lands in the water 4 meters out from the cliff, oh, well, that's in the horizontal, isn't it? Okay, so from here, from the cliff, he goes out 4 meters. Well, that's going to be dx. We want to know how fast did he run off the cliff? Well, he ran off the cliff in that direction, right? So Vx is now our unknown. Now, the trajectory is going to look like this. It's still a half parabola. It's just kind of narrow. Okay, mistake that students want to do with problems like this. They see that there's 4 meters on the bottom, there's negative 15 meters on the side, and they immediately want to make a triangle and then do Pythagorean theorem. You cannot do that. And it's because 2 reasons. One, this is a curve, okay? This trajectory, it's a curve. It's not a line. The other reason is if you were to find that, I mean, like, I don't even know what that would give you, but we're looking for how fast, right? You can't use meters and meters and then figure out meters per second. Like that's not possible. So do not make a triangle. The only time you make a triangle is if you are given an angle. It's in the word. If you don't have an angle, do not make a triangle. So what should we do? We should chart it. All right, let's see, here we go. X, we have, let's see, the first is G and then VX. VX is our question mark, that's what we're looking for. Let's see, we got time, and then we have DX. DX is given to us. Well, look there, we got two unknowns on that side again. Let's see, let's look on the Y side here, the blue. We have G, which is negative 9.8 meters per second squared. VIY, which again, since we're running off, then we know VIY is always going to be 0 at the top of this path. So that's 0. We don't have that one. And we do have DY. All right, negative 15 meters. All right, let me get my purple going here. So, because this is going to be the same time. Red and blue make purple. All right, we only have one unknown on the Y side, so let's use that one again. And it's the exact same equation again. There is a sequence to this. You make the chart, you pick which side you need to solve, and then you use that one equation for that side. So dy equals 1/2 gt squared plus viyt. Let's see, negative 15, 1/2 negative 9.8 t squared, that's a 9, plus 0 times t, that drops. Negative 15 equals negative 4.9 times t squared. And again, I'm going to put parentheses around that to emphasize it is multiplying. So now we divide by negative 4.9. And we get 3.06. To get t, we take the square root of that. And so t is going to be 1.75. Okay, now we've got time. Let's put it in purple. And now we can solve for Vx. All right, so on the x side, we only have that one equation. We have Vx equals dx over t. Well, hey, we're looking for Vx. Let's go ahead and use that one then. Vx equals 4 divided by 1.75. And so let's see what we get with that one. Let's see, 4 divided by 1.75. Got 2.29 meters per second. All right, there we go. There's your two examples. Hopefully this helps for solving some problems, and let me know if you need anything else.